Okay, so we're continuing on quadratics. We're looking at the vertex today and how to calculate it ourselves. So we still have our function f of x equals ax squared plus bx plus c, where a is not 0. We're going to add a little formula to this that's going to help us out. The axis of symmetry can be calculated. I remember how to spell symmetry. It's always this line that x equals, and it's negative b divided by 2a. Okay, so I would definitely write this one down. Axis of symmetry, x equals negative b over 2a, where x isn't a number, but it's an equation of a line. So the whole thing is what you put. X equals some value. Okay. I don't really want to get into where that formula comes from because we don't need to know that, but it is pretty interesting. If you look up, go on your Google, type y is axis of symmetry negative b over 2a, and you get some interesting explanations. All right, for today, we want to find y-intercept axis of symmetry in the vertex for this function here. So easy one first, the y-intercept. So we know the y-intercept is always just this c at the end. So our y-intercept is -3, or we could say that's 0, -3, depending on how they ask for it. Okay. All right, the axis of symmetry, that's what we just talked about. We said that's always going to be x equals negative b over 2a. So we just fill in our values. So x equals negative b, so that'd be -4 divided by 2 times a is just 1. So -4 divided by 2, we get x equals -2. So there's our axis of symmetry. Okay. All right, now the vertex. So if we think about what we've done so far. So where can I put this? Let's just put it right here. Why not? So here's my plane, and I know my axis of symmetry is that x equals -2. Okay. So my vertex is somewhere on that line. So the x value of my vertex is -2. So really what I need to know is what is the y value of that point. So I'm going to take my function. We're going to say x squared plus 4x minus 3. And I'm just going to solve that, put the whole thing, when f of x, or when x is -2. So we want to know, let's do this in, let's be done Greek. So we want f of -2 is equal to -2 squared plus 4 times -2 minus 3 more. Okay, so all we did, we just took our function and we swapped everywhere we had an x with our axis of symmetry value. Okay, I did want to point this one out because I saw some people had trouble with this on Monday. When you are doing a, okay, I don't want to say this. The value of a squared, or ax squared rather, will always match the value of a itself, or the sign of a itself. So since a here is just 1, it's not written, but since it's just x squared, it says 1x squared. That has to be positive, right? Because no matter what x is, if you square it, it will always come out to a positive value. Okay? So like -2 squared, that equals 4. So the only time ax squared can come out to be a negative is if the coefficient, if a itself is negative. So it has nothing to do with the value of x, it has everything to do with the value of a. So be careful when you square, because this is really the only place I saw people making math mistakes. All right, so that's 4. 4 times -2 is -8 minus 3 more. So 4 minus 8 minus 3 is -7. So f of -2 equals, I should write this better, space it out. So f of negative 2 equals negative 7, which means our vertex would be at negative 2, negative 7. Okay, so I find the axis of symmetry, that gives me my x value. Substitute that into the function to get the y value. And then I have my vertex. Might be a little bit further down than that. So what we can do, this doesn't ask us to, but if we have these 2 points, we have our y-intercept, we have our vertex. If we plot both of those, and just with those 2 points, we can get a pretty good idea of what our graph should look like. Because I know that this is going to go up like this forever. And since this is the axis of symmetry, anything on the right side is going to be the same as what's on the left side. So I could put a mirrored image of my y-intercepts on the left, and then I can draw the other half. And just with 2 points, I can come up with a pretty rough sketch of my entire parabola. Now, might be helpful in case you don't want to have to go to your calculator and graph it yourself. All right, second half, determine whether the function has a maximum or a minimum, and then state the value. State the value in the domain and range of the function. I feel like it's or has too many words there. State the value. What's the value? Oh, the value of the minimum or maximum. Duh. Okay. All right, I'm caught up now. So we can figure out if it's minimum or maximum just by looking at this value here. If a is negative 4, hopefully you remember that means that our graph is opening downwards, right? And so this point up here would be our vertex. Since that's at the top of the curve, we know this is going to have a maximum. Okay, so what we need to determine is what is the maximum. So I need to know what is my vertex. So then I'm back to what I did here. I need to know what's my axis of symmetry, and then what is the y value at that point. So we can say, same as before, x equals negative b over 2a. So in this case, we would have negative 12 divided by 2 times negative 4. Ugh, that's not great. That's a decimal. So 12 divided by 8 is 1.5. Negative divided by a negative is a positive, so at least we have that going for us. So here's our axis of symmetry. That doesn't help us. We just need that to get the vertex. So I'm going to take my function, and I'm going to replace all of my x's with 1.5 to solve for y. This works out. Okay, so 1.5 squared is 2.25. Trust me. 2.25 times negative 4, that just works out to negative 9. 12 times 1.5 is 18. Yeah, plus 18 more. So negative 9 plus 18 is 9. 9 plus 18 is 27. So f of 1.5 equals 27, which means my vertex is at 1.5, 27. Or the maximum value, the highest point would be 27. So maximum of 27. Is that how they ask for it? Let me make sure. Oh, maximum equals 27. Okay. And then it wants you to write out what's the domain and range. So a couple things. Give you a crash course on how to write domain and range in set notation. So domain of any quadratic equation, any of them, forever, is all real numbers. So we say the set of curly braces, all real numbers. Close curly braces. Okay, that's always going to be the case. If you see an answer choice where it says domain is something other than all real numbers, just cross that one off. It can't be real. Okay. The range, on the other hand, that is a bit limited. Because if you look, here's our graph, right? It has a maximum point, which means it cuts off at 27. It can't go above 27. So we say, if we want to write this out, the range of this is f of x. So it's saying for this function, we put this called pipe, just a solid line. It's not a 1 or an L, it's just literally a line. And that just means such that. And we want, what do we want? F of x to equal, or not to equal. Let's start with 27. This is always going to be an inequality. What is true about the value of y? Is it less than 27 or greater than 27? And since it's the maximum, it cannot go above that number, so it has to be less than or equal to 27. So this is how you'd write it out. A set of numbers, curly braces, of f of x such that f of x has to be less than or equal to 27. And if you say, Ellis, that's too confusing, I can't remember all that. If you look at the answer choices, it's all multiple choice. So hopefully when you just see them, it'll make more sense. We're looking for, you want the minimum or maximum to be this number here. If it's the maximum, it has to be less than that. If it was the minimum, you would want f of x to be greater than that number. And domain will always be all right numbers. So hopefully you can use your common sense, your good math skills. You can get through this. If not, feel free to ask me questions and we'll help you out.